This system is not settled. It only appears steady. Navigation relies on timing. Electricity depends on phase. Coasts respond to small forces. Changes that normally unfold across ages can arrive in hours. Not in decades, but within a single pass. The first changes are slow to see. Then instruments notice. Then shorelines feel it. Early signals are quiet. The later ones are not. The world keeps working. Differently. A very large asteroid passed by Earth one day. It missed our planet by approximately 500 kilometers. For objects moving at cosmic velocities, this distance is remarkably small, not the cataclysmic end of life long imagined in fiction and feared by scientists. Instead, the close passage initiated subtle but significant changes across the globe. The sky, the satellite shell, the oceans, and the infrastructures we built all registered the near miss. A flicker overhead became a boom, a minor orbital shift became outages, and a faint tide fluctuation became new costs. The first sign for most of humanity was purely visual. A brilliant, silent line appeared in the sky, far brighter than any meteor or airplane. For those beneath its trajectory, a piercing point became a blazing divide across the heavens. For minutes, it shone like a small secondary sun, casting sharp, moving shadows. The light came from friction in the thin air, a sheath of incandescent plasma. Crowds watched, feeling a dry, intense heat radiate from far aloft, alien to the night. Dust and small fragments shed into the upper atmosphere and stayed suspended. They formed noctilucent veils, refracting moonlight and starlight, dimming familiar constellations behind silvery gauze. A spectacle of light and heat, followed by a luminous haze that persisted for weeks. Long after the streak faded, a second phenomenon swept the planet. The sonic wave took time to descend from the thin upper air. It arrived as low, rolling thunder that seemed to come from everywhere at once. Windows rattled, alarms cascaded, animals grew agitated, and flocks burst skyward. The wave still carried enough energy to produce minor structural stress. Calls surged before the cause was widely understood. A physical jolt followed the spectacle, vibrations, minor damage, and a shared unease. No collapses, no firestorms. Just the unmistakable proof that speed and altitude can translate into felt force, late but real. The asteroid cut a swathe through the exosphere and thermosphere. Acting like a piston, it compressed and superheated the tenuous gas to plasma temperatures. A long channel of ionized, denser air formed, invisible from the ground, but persistent. Unusual reactions broke nitrogen and oxygen, forming nitric oxide and temporarily reducing ozone at high altitude. Sensors logged anomalies for weeks as chemistry and heat relaxed toward normal. Low Earth orbit felt it first. Satellites passing through met unexpected drag, losing a sliver of velocity and altitude. Like a car suddenly hitting deep water, tiny path errors multiplied, increasing close approach risks and complicating traffic management. Thermal and chemical disturbance became orbital drag, the first link in a longer chain. Operators carved corridors through the invisible hazard, buying time with fuel. Every correction spent propellant and shortened useful lifetimes, a quiet cost with loud implications. Then, the dependencies downstream began to wobble. Timing, navigation, communications, and the human systems leaning on them. The sudden drag triggered a global technological crisis. Hundreds of satellites saw accelerated orbital decay or riskier conjunctions. Emergency maneuvers consumed propellant, cutting expected lives from 10 years to 7, 5, or less. On the ground, position errors, dropped calls, and stalled live broadcasts became everyday irritants. Pilots and ship captains shifted to backups, slowing schedules and raising workloads. Meanwhile, the transient gravity tugged at the most mobile surface system, the oceans. A low, broad swell raced outward far faster than wind waves or tsunamis. At shelves and inlets, energy compressed, producing brief, sharp surges. Boats tugged, minor bumps and closures followed, disruption more than devastation. Sandbars rearranged, nearshore ecosystems momentarily stirred. Power systems keep phase using precise satellite time. When signals faltered, controls fell back to local clocks. Minuscule offsets accumulated into phase differences, stressing transformers and breakers. Relays isolated trouble, creating scattered blackouts that most crews reversed within hours. Start-stop cycles strained older gear, extending outages for some. Factories paused, businesses shut for a day, and daily life stuttered. The lesson: reduce single-point timing dependencies. Grids stabilized, but the experience exposed a hidden hinge in our energy architecture: time itself. Markets absorbed the near miss with sharp uncertainty. Satellite disruptions, shipping delays, grid instability. Risk sold off, safe havens bid. Indexes dipped, then steadied. Underwriters tallied property claims and business interruption, then faced the pricing question. Premiums rose where dependencies were clearest. Supply chain ambiguity moved energy, metals, and grain. A deluge of posts mixed awe, fear, and misinformation. Agencies and observatories launched an information campaign as instruments captured the event in detail. Astrophysics, oceanography, and atmospheric chemistry built collaborations around a trove of data. Responders audited timelines and refined protocols for low-probability, high-impact events. Public interest in the sky surged and culture took note. With the public watching, funding for detection and tracking gained momentum. After the intensity, a pause. The glow softened, the rumble receded, and systems sought a new balance. The near miss demonstrated how a distant mass can link skyfire to spreadsheets and plasma to paychecks without touching ground. In the months and years that followed, life returned to routine. The luminous haze faded as dust settled out. Grids stabilized and satellite services fully returned. Supply chains regained their rhythm. But beneath normalcy, structural changes took hold. Global coordination and transparent data sharing. Satellites hardened and learned to maneuver smarter. Enterprises layered redundancy to blunt timing and comms shocks. Models improved. Textbooks added non-impact chapters. A benchmark case was born. The memory persisted, a world that looked up together. One object brushed past and touched our sky, our oceans, our technology, and our economy, all at once. It was not a test we passed, but a lesson we were given. We had been lucky. We adapted, learned, and fortified. The question that remains is simple and unresolved. Knowing our fragility, what will we do before the next one comes? What scenario should we explore next? Share your ideas below. You've been watching Ifverse, where imagination meets possibility. See you in our next reality.